All right, we're going to do section 8.3, trigonometric integrals. So here's some guidelines for the powers of sine and cosine. Number one, if the power on sine is odd, save one sine for du and convert the others to cosine. Okay. If the power on cosine is odd, save one cosine for du and convert the others to sine. If all powers on sine and cosine are even, make use of sine squared x equals 1 minus cosine 2x over 2, and cosine squared x equals 1 plus cosine 2x over 2 to convert to an odd power of cosine and apply guideline number 2. Okay, let me close the door. Okay, use the Pythagorean theorem identity, sine squared theta plus cosine squared theta equals 1. This is going to be very useful for this portion of this section, okay? Obviously use the other stuff as well, but so have your cheat sheet out for trig functions and the integrals and derivatives of all. All right, example 1, we're going to integrate the integral of sine cubed 2 theta, square root of cosine 2 theta d theta. Okay, so according to our rule, if our sine power is odd, we save one sine, so let me separate them. So I have the integral of sine squared 2 theta, sine 2 theta, and then the square root of cosine 2 theta, d theta. I don't know why my dogs decided to fight right now. I'm giving them the stink eye, but they don't look at me. All right, so this is the one that I'm going to separate, right? It says to separate one, and that's the one we're going to use for du, and we convert the other ones to cosine. Well, how am I going to convert sine squared 2 theta into cosine? Well, remember that formula I told you we're going to use? Can I say that sine squared theta is equal to 1 minus cosine squared theta? Would that be useful? So I have the integral of 1 minus cosine squared 2 theta, because I have 2 theta, times sine 2 theta, the square root of cosine 2 theta d theta. Okay, now I'm going to distribute not the sine 2 theta, but this portion of it here. I'm going to use that to distribute this whole thing with everything that's in here. Okay, and I'm going to rewrite it. So I'm going to rewrite this as cosine 2 theta quantity 1/2. Okay, so just so that's a little bit easier to handle. Okay, so times itself would just be cosine 2 theta to the 1/2 minus, okay, so this is, we have a square, so cosine 2 theta, so we have a square plus a half, so that would make it 5.5. Okay, and then times sine 2 theta d theta. Okay, so this now we can use the u substitution and make cosine 2 theta and then du. So if we take the derivative, it becomes negative sine 2 theta and then d theta. And then we take the inside, so it gives out a 2, okay? For the inside, for the 2 theta. So what I'm going to end up using is negative 1/2 du equals sine 2 theta d theta, right? Because that will, let me change the color. So this, oops, it didn't change the color. So this portion will then substitute that, okay? So let me go back and do the substitution. So on the outside, I have a negative 1/2, and the integral of u to the 1/2 minus u to the 5/2 du. So this is much easier. So negative 1/2, and then the integral would give me, I add 1, so u to the 3/2, so then 2/3 out here, and then minus u to the 7/2, and then 2/7 out here, and then that would give us, I'm gonna just put the plus c so I don't forget it, right outside. So then here, I'm gonna do two things. I'm gonna distribute this half, negative 1/2, I should say, and I'm gonna change my u's. Okay, so I'm gonna give you, substitute it back. So then this will give me negative 1/3 cosine 2 theta to the 3/2 plus 1/7 cosine 2 theta to the 7/2 plus c. Okay. And then b. We have the integral of cosine 4 to the 3 alpha, that's an a, and d alpha. So if the powers of cosine are even, let's make use of cosine squared x, so number 3, option number 3. So what I'm going to do is I'm going to rewrite it so I have cosine squared. So I rewrite it as cosine squared 3 alpha quantity squared d alpha. Okay, then I'm going to, inside, I'm going to rewrite it with 1 plus cosine. Okay, so be careful here. 1 plus cosine, the formula says 1 plus cosine, 2x over 2. And this is for cosine squared x, okay? So this 2x, 3 alpha will give me 6 alpha over 2 quantity squared d alpha. Okay, so then what I'm going to do is I'm going to take out the half, but it's squared, so I really take out the 1/4. Okay, and then I'm going to multiply, so using the box, I use the box, you can FOIL, bad word, the numerator only, because I already took out the denominator. So I have 1 plus cosine 6 alpha, and then 1 plus cosine 6 alpha. So it's going to give me 1. This is going to give me cosine 6 alpha. This is going to give me cosine 6 alpha. And this is going to give me cosine squared 6 alpha. Okay? Or if you don't want the square here, you want it on the outside, whatever. It doesn't make a difference. So then I write 1. Oops, let me take it out of red. I write 1 plus 2 cosine 6 alpha plus, I'm going to write it on the outside, cosine 6 alpha quantity squared dx, d alpha, not dx. Okay, well, what do I have here again? Yep, so I need to rewrite it. Let's do this half of the integral, right? So and then I'm gonna distribute that 1/4 to everybody just because that last one's gonna change. So let's just do 1/4 d alpha plus 1/2 cosine 6 alpha. Oops, I forgot to give it its integral. D alpha plus 1/4 the integral of, and then that's gonna change to be 1 plus over 2 cosine. Remember that was a 2x. Now I have a 6x, so it's gonna give me 12 alpha. I mean, I have 6 alpha. D alpha. Okay, so here this gives me 1/4 alpha plus 1/2 sine, because what's the integral? 6 alpha, integral of cosine is sine. And then I need to take the integral of the inside, so that would be 1/6. Plus, I'm going to take out the 2, 1/8. And then again, I have 1 plus cosine 12 alpha d alpha. Okay, and I'm going to do the same thing with this, distribute and give everybody its own integral. So let's simplify. So I have 1/4 alpha plus 1/12 sine 6 alpha plus, and then I'm going to do the integral of 1/8 d alpha plus the integral of 1/8. Actually, I'll leave that one out. Of 1/8 cosine 12 alpha d alpha. Okay, so I have 1/4 alpha plus 1/12 sine 6 alpha plus 1/8 alpha plus 1/8, and then the integral of cosine again is sine. I have 12 alpha and then times 1/12 for the inside, and then plus c. So let's simplify, and then I have like terms. These two are like terms. So that'll give me 3/8 alpha plus 1/12 sine 6 alpha plus, this will give me 1/96 sine 12 alpha plus c. Okay, so now guidelines for powers of secant and tangent. So number 1, if the power on secant is even, say 1 secant squared x value for du and convert the rest into tangent. 2, if the power on tangent is odd, save 1 secant tangent for du and convert the rest into secants. If there are no secants and the power of tangent is even, convert a tangent squared value into the secant squared value. 4, if I have the integral of secant to the n power of x dx, use the integration by parts with dv equaling secant squared x dx. Okay, and then of course we love integration by parts. If none of the above work, try converting into sine and cosine. Okay, the equation that's going to be helpful here is going to be that secant squared x equals 1 plus tangent squared x. Okay, I thought I typed it up, but I didn't. Sorry about that. And these go in order. So when you're looking to see which one to use, start with the first one. If it doesn't apply, then go to the second and so on. So do it in order to find it, okay? So let's do example number 2. And we're going to integrate secant 6 to 3x dx. Okay, so number 1 is the option here, and we have that secant is even. So it says save 1 secant squared x. So I'm going to do, oops, let me change it back to black. So I'm going to do, I'm saving 1 secant squared x. So that leaves me with secant to the 4th 3x times secant squared 3x dx. Okay, and then it says, and convert the rest into tangent. So I have to convert secant to the 4th 3x into tangent. Well, I'm going to use this helpful equation here. Okay, so let me rewrite secant as squared. So secant squared 3x quantity squared times secant squared 3x dx. And so I'm going to change that to be the integral of 1 plus tangent squared 3x. I was about to write x. 3x quantity squared, and then we have secant squared 3x dx. Okay, so again here, I'm going to foil, do the box. I want to say you foil. I don't like foil. Anyways, let me get over it. I have 1 tangent squared 3x, 1 tangent squared 3x. So 1 tangent squared 3x, tangent squared 3x. And then this gives me tangent to the 4th power 3x. Okay, so this bottom here gives me 1 plus 2 tangent squared 3x plus tangent to the 4th power 3x. And then this whole thing multiplies secant squared 3x. And don't distribute here, okay? Because we purposely are leaving that secant squared out, okay? So from here, I'm going to substitute u. And I'm going to say u is going to equal tangent 3x. So du is going to equal secant squared 3x. And then times 3, because the inside, dx. So this is in reality 1/3 du equals secant squared 3x dx. Okay, remember we didn't put it back in so that can get substituted. So then I have 1/3 the integral of 1 plus 2u squared plus u to the 4th du. So then this gives me 1/3 times u plus 2/3 u cubed plus 1/4, or 1/5, sorry. 1/5 u to the 5th, and then plus c. So I'm going to distribute the 1/3, and I'm going to substitute back the u. Okay, so I get 1/3 tangent 3x plus 2/9 tangent cube 3x plus 1/15 tangent to the 5th power 3x plus c. Okay, so now I have the integral of secant to the 5th x tangent cubed x dx. So if the power of secant is even, nope. If the power of tangent is odd, yes, this is what I have. Say 1 secant tangent for du and convert the rest to secants. Okay, so I'm going to save 1 secant tangent. So if I take out 1 secant, this is going to give me secant to the 4th x times tangent squared x, and then secant x tangent x dx. So in parentheses, that's what I'm saving. So this is what I'm saving for du, basically this whole bottom stuff. Okay, so now if secant, oh, and then it says, and convert the rest into secants. So tangent squared to squared x, so secant 4 to the x times secant squared x minus 1, and then times secant x tangent x dx. I will distribute here, just this part here. So I have the integral of secant 6x minus secant 4x times secant x tangent x dx. Okay, so here I can substitute u equals secant x. Du will equal secant x times tangent x dx. Okay, so then I can take the integral of u to the 6th minus u to the 4th du. So this is going to equal, oops, the integral is gone, sorry. 1 over 7 u to the 7th minus 1 over 5 u to the 5th plus c. And then I'm just going to substitute. Oops, 7 is in the denominator. So 1 over 7 secant 7th x minus 1/5 secant 5th x plus c. And we're done. Okay, now we have the integral of secant cubed x. Okay, so if we have for number 1, secant is even, nope, tangent is odd. If there are no secants, that's not true either. If secant to the n power of x dx, then we use integration by parts, and then it's saying to dv is going to equal, actually let me write it, because integration by parts, so then we're going to have u equals dv equals, that's not where I want dv, du, I want v here, and I want dv here. So dv is going to equal secant squared x dx. Okay, so if dv is going to equal secant squared x dx, then how many more secants do I have? And you should be saying 1 more, and that's what u is going to equal. So then du is going to be secant x tangent x dx. V, so the integral for secant squared x dx is tangent x. Okay, so remember, u is going to multiply v. So we have secant x tangent x minus the integral of v du. So this is going to be secant x tangent squared x dx. Okay, well, tangent squared x, I'm going to make them all secant. So that leaves me with secant x tangent x minus the integral of secant x times secant squared x minus 1 dx. So secant x tangent x minus the integral, I'm going to distribute, secant cubed x minus secant x dx. Okay, let me separate this integral. So this gives me secant x tangent x minus the integral of secant cubed x dx plus, because that negative distributes, plus the integral of secant x dx. And we're going to kind of do something we did in section 8.2. So this here, if you notice, is what we started off with. Okay, so reality, this is equal to secant cubed x dx. What did we do the last time we had it on both sides? We used it as a variable, remember? So I'm going to add the integral of secant cubed 3x dx to both sides. So this will give me 2, the integral of secant cubed x dx, which is equal to secant, not sex, secant x tangent x plus, what can we take the integral of secant x dx? Yeah, so that's actually going to be, or actually let me finish this before we take the integral. Okay, because what am I going to do next? I want to divide everybody by 2. So then this gives me 1/2 secant x tangent x plus 1/2, and now I'll take the integration. So natural log of secant x plus tangent x, absolute value, plus c. Okay, and the reason we're doing this is because we don't have a secant odd. Okay, we have a secant even. Okay, so then we use it as like a variable. Okay. All right. So let's recall the product to sum formulas. So more trig stuff, right? So and then I had some stuff written. I don't know why I didn't write it. So we have sine A times sine B is going to equal 1/2 cosine A minus B minus cosine A plus B. We have sine A cosine A B. This is 1/2 cosine A minus B plus sine A plus B. Cosine A times cosine B equals 1/2 cosine A minus B plus cosine A plus B. Okay. And then these properties allow us to reconcile different angles. Okay, so for an example 3, we have to integrate sine negative 4x cosine 3x dx. Okay, so what we need to remember here is the even and odd identities. So you can take care of it from the beginning, or you can wait till a little bit later. Up to you when you want to take care of the even and odd identities. But basically, so it's on your list of trig stuff, the list that I gave you. So basically, if you have it memorized, then cool. If you don't, cool. I mean, you can use it. You have it there. But basically, everybody becomes negative except for cosine and secant. Cosine and secant both become positive. Everybody else becomes negative, okay? So like I said, if you want to take care of it now, you want to take care of it later, 100% up to you. I'm going to take care of it later, okay? So what I'm going to do is I'm going to apply these rules. And I have basically the second one. I have sine A times cosine B, okay? So then this is going to give me, and I'm going to put the 1/2 outside of the one that it gives me. So I have sine negative 4x minus 3x. And then I have plus sine negative 4x plus 3x dx. And then I put everybody in a bracket. Okay, let's simplify that. So I have 1/2 the integral of sine negative 7x plus sine negative x dx. Okay, and then, so this is where I need to apply those even and odd identities. They're both sines, so they're both going to stay negative. So I get 1/2 the integral of negative sine 7x and then minus sine x dx. Oops. Okay, well, if you notice, they have a GCF of negative, so I can pull that out now. And so I just have the integral of sine 7x plus sine x dx. Okay, so I can take the integral. So here I have negative 1/2. And then the integral of sine 7x would be negative cosine 7x. And then the integral of the inside. So then I have 1/7. I'm going to put that in parentheses, that's fine. And then I have minus cosine x plus c. So let me distribute. So this becomes 1/14 cosine 7x plus 1/2 cosine x plus c. Okay. If you want to take it out from the beginning, you can. Okay. Let me change the color. I'll do it in green. So if you want to take it out, right, you know that sine is going to be negative. So then I can take it out completely and just say I have negative sine 4x cosine 3x dx. And then just work with leave it outside. We took it out anyways, right? So it would still turn out to be exactly the same. You're still going to get 7x, right? When you add them, when you subtract them, you're going to get x. So that's what I'm saying. If you do it in the beginning, you're fine. If you do it a little bit later, you're fine. As long as you do it, it doesn't matter at what point you do it, okay? So from here, then we would have just had that negative in the front from the beginning instead of getting it over here. All right, and I believe we are done.